like this. So this is the radius of the let me take this initial. It's having some initial velocity. Now, what is that A tangential? I am writing retardation, no? Retardation means it should act opposite to this one. So this will be 80. Put like this. Then what will happen to speed of particle? Continuously decreases. This is at t equal to 0. Okay, now come for this. First, can we do one thing? Can we calculate angular retardation? So let me go for all the calculation. Equal to r alpha. What is 80 minus 1? R is 2. So what is alpha? Minus 0.5 radians per second square. This is alpha. So once we know alpha, then we can calculate the at t equal to 2 seconds. So we should calculate at t equal to 2 seconds also what is alpha. So let's say the particle describes constant angular retardation. So what happened to alpha? Alpha will remain constant. So what will happen to normal acceleration? Normal acceleration is going to change. It will not going to remain constant. The normal acceleration will continuously change. Initially it will have some value. And the total acceleration vector will be somewhere like this. This is at t equal to t equal to 0 after some time. So somewhere here we'll take it. Anything? So let me just pick up this point. Because of alpha, let's go for omega. What is omega? Omega naught plus alpha t. 10 minus 0.5. Look at this. Omega also keep on decreases. No, is asking it t equal to 2 seconds. So 10 minus 1 by 2 into 2. So this will be 9 radians per second. This will be omega. Okay, after getting omega, then can we calculate A normal? Omega square r 9 square into 2. This will be 81, 162 meter per second square. Very large value, no? Usually it happens here. Okay, now we got total. What is the tangential acceleration? Tangential is given 1, and A normal is this much here. Okay, what is the total acceleration then? A normal square plus A tangential square. Then somewhere after some time, it will be having V tangential, A tangential, A normal. This will be A tangential. The total acceleration vector will be like this, and this should be the beta. This is initial A naught, you write it better. This is at any time, or say t equal to 2 seconds. So what is beta? Here also the same formula, nothing will change. So an by 80. So what is the value of an? 162. A tangential is 1. Don't write minus sign. So let it be like this. Tan beta. And don't show an opposite. Don't show that an radially outwards retardation. Whether acceleration or retardation, an will be towards center only. Okay, this, so this is about the A tangential. Okay, next after this, what we are next things are beta got over 10 beta. So number of revolutions is asking. So for that we need theta, no? So what should be the formula for this? Theta equal to omega naught t plus alpha t square. Omega naught 10. Time given is how much? 2 seconds. Alpha is how much? 0.5. 2 square by this is 2. So 20 minus 1. So this will be 19 radians. Number of revolutions n equal to theta by 2 pi. 19 by 2 pi. How many revolutions it will complete? Around here also, you can check it.
3.02.
3.02. So what does it mean? So it goes round. It goes round like this. 1, 2, 3. So finally, what when it come to rest here? Tell me, what about the time taken to complete successive revolutions?
Increases.
It increases, no, retardation. So time taken for successive revolutions increases. So it can be angular acceleration retardation, but whether angular acceleration or retardation, what should be the centripetal acceleration? Should be directed towards center. What about show alpha direction? So here, what is omega naught? Like this. What about alpha? Alpha like this. There's a one thing which will help us a lot. The initial angular velocity will be like this. Alpha should be opposite to omega because it's a retardation. Okay, these are the some, they can ask you any of the questions here, no? Okay, let's go for now the variable circular motion. Means if angular acceleration varies with the time, with the distance covered or with the theta, then how to manage the numericals. So that number of revolutions, don't forget. Now, if they give omega, you see that anybody noticed when you purchase ceiling fan, they write RPM, no? They don't. Nobody write angular velocity or angular speed in terms of radians per second, RPM. So when you purchase ceiling fan, it'll be written no 250 RPM, 300 RPM, 120 RPM. What is that RPM? Revolutions per minute. The reason for that, when you look at fan, in 1 second, what will happen? How many revolutions it will make out? So let's say that 360 revolutions per minute. What do you mean by that? So I'm having a fan where it is having 360 RPM. It'll be written. So what do you mean by that? 360. One revolution. And this is the unit here. So one revolution, how much it will make it? 2 pi. Then per minute is how much? 60 seconds. So look at now. So this will be 12 pi. So 12 into pi approximately 3.14. So this will be around 36. So what is the 12 into 37.68 radians per second. Tell me, like, which will give better information, 360 RPM or 37.68 radians per second. Definitely, I prefer this one. So in 1 second, what it will happen? It will have an angular displacement of 37.68 radians. You convert this into further degrees, you'll get a better, still more better picture. So therefore, if you see the practical unit for angular velocity is not radians per second. In fact, it is revolutions per minute. So if they give RPM, how to convert radians per second? You have to do that. If they give radians, how to convert that into RPM? Suppose another situation, omega 2, where it is say like 60 radians per second is there. How to convert this into RPM? 60 is there. So I should write, I'll divide by 2 pi because one revolution is 2 pi. Then per minute is there. So what I should do here? So I'll do one thing. RPM, I should write it, no? Where I'm bringing revolution, I'm bringing in the numerator. So denominator, I should adjust 2 pi. Per minute. Minute is what here? Because seconds is there. I'll do one thing. This will be 60 radians per second. So per minute means 60 seconds I should bring it, no? So here one revolution or like how many radians will become one revolution? So 2 pi radian. So here 2 pi radian. The next what I adjust is 60 seconds. So here I should adjust 60. Getting the idea? I'll rewrite again. So 60 I'll keep it here. So 2 pi radian by 2 pi. I think I didn't change anything. Then 60 by, I'll write some 40 value. 60 by 60 seconds. Okay, you adjust things now. 2 pi radian will become one revolution. So 40 into, this will be revolution by 2 pi. This will be 60 by per minute. So now you make it. So 1000, 24 by 2 will be 1200 pi RPM. So if they give radians, you can convert into RPM like this. If they give RPM, you can convert into radians. Very popular unit. Practically, we do use revolutions per minute, RPM, than radians per second because this will not give much better information. Okay, this is about the expressing angular velocity. But the angular acceleration, I'll prefer to express in terms of what? Radians per second square only. So if they give RPM, you have to convert into revolutions per second. Sometimes they'll ask you the end answer in terms of RPM. So convert into this way. So this is about the conversion from RPM to radians per second for angular velocity. Okay, got the idea? So just see once. So you do have questions of like this. So don't get confused. This is a method. So next time the ceiling fan, any rotating object, any rotating object, RPM will be mentioned. Just do make observation. Don't blindly just watch color something and all. You want to become engineer. You should watch you should make observation of technical things, not